Saildrone has spent more than a decade building incredibly tough, long-endurance autonomous vessels powered by wind and solar energy, mainly for ocean research and mapping. Now, they're taking that same technology in a very different direction, developing a super quiet, long-range craft designed to hunt submarines. At first glance, that shift might seem surprising. A company known for peaceful ocean data collection, stepping into submarine warfare sounds like a big leap. But when you look at how naval strategy is evolving, it actually lines up pretty well. Modern navies are moving away from relying on a small number of large warships. Instead, the future is about bigger fleets, made up of both crewed ships and autonomous systems that can cover huge areas of ocean more efficiently. That's where these robotic vessels come in. Smaller, unmanned craft can handle wide area patrols and specialized tasks, freeing up major warships to focus on more critical missions. And when it comes to tracking submarines over long distances, sail-powered vessels have some unique advantages. Sailboats are naturally quiet, which is a huge deal in underwater detection. Their hulls also tend to be less visible to sonar, making them harder to detect. There have even been real-world cases where submarines surfaced and accidentally collided with small yachts because they couldn't detect them. So, an autonomous sailcraft towing acoustic sensors could be a very effective and stealthy platform for detecting and tracking submarines. Building on this idea, Saildrone has introduced two versions of its new Spectre unmanned surface vehicle. Both are based on the company's earlier designs and are made from aluminum. They're being built in partnership with Fincantieri Marinette Marine in Wisconsin, with a production goal of about 5 units per year. Saildrone is also working with Lockheed Martin to integrate proven combat systems, including the Mark 70 vertical launch system for missile deployment. Both Spectre variants are designed for serious range, capable of traveling up to 8,000 nautical miles. They can also carry heavy payloads, up to 25 tons, which can be configured as standard shipping containers or equivalent mission equipment. The main difference between the two comes down to how they move. The Spectre Silent Endurance uses a massive composite wing, standing about 140 feet tall, to harness wind power for ultra-quiet and efficient long-distance travel. On the other hand, the Spectre Stealth Strike swaps that wing for diesel engines, allowing it to reach speeds of up to 27 knots. It can also switch to electric power for quieter operation at lower speeds when needed. The design has already received approval in principle from the American Bureau of Shipping, which is a big step toward real-world deployment. A prototype is expected to begin sea trials early next year. According to Saildrone's CEO Richard Jenkins, the Spectre isn't something rushed together to meet a quick demand. It's the result of over 2 decades of refining ideas and learning from real-world operations. The goal is to create a system that fills critical gaps in anti-submarine warfare while pushing the limits of what autonomous vessels can do out at sea.